Now, let's introduce 242 Series motion controller. This is a 242D motion controller. D represents double plug-in terminal. 242 series grade and serial number are here. Black terminal is for motor connection. Double plug-in terminal is terminal for power and communication. This is 242 integrated motor. The code number of motion controller. The serial number. The connector. It is already connected with motor internally. The power source and the control terminal. Middle part is internal encoder. This is a 242T motion controller. T represents green screw terminal. To connecting 242 series, we need 242 motion controller, 2502 gateway, leader cable, and some connection cable. Now, let's connect 242 series products step by step. First, the wiring scheme for network operation. Here we have a CAN line with a branch at each node. Please note, 242 is not a load star connection, which means it's not allowed to connect all CAN nodes to one branch. Star connection will interfere CAN network communication. Also, CAN main line need to be standard CAN signal cable. P-type plug can be plugged in directly. T-type plug need to be screwed in. Connect the negative electrode to port 2. CAN high-level line and low-level line are connected to port 3 and port 4 respectively. Now we have 3 motors on CAN network. Please note, we need to add 120 ohms resistance at the CAN H and CAN L each. After finishing connecting, let's measure the resistance value of CAN main line. Switch the multimeter to ohm. Connect the red-black pan of multimeter to white-blue end. We will see the resistance is close to 60 ohm, which is standard for CAN main line. Next, connect the head of CAN main line to gateway. One end of the serial line is connected to gateway, and the USB end is connected to computer. Last, Connect the power source. Positive electrode is with red line. Negative electrode is with black line. Up to now, we have accomplished the connection of 242 and CAN network. After connecting 242 series with CAN network, double-click to open step-over for step motor control. 2502 gateway will be found from here. Connect to the gateway. Gateway serial baud rate is showed. CAN bit rate is also listed. Now step-over will search all sites and register all of them. Number 7, 8, 9 motion controller will be found on CAN network. They are listed here. Edit each site individually. Select a specific site. Change site number 9 to number 6. CAN bitrate can be edited here. When edit CAN bitrate, it actually changes all nodes. All three models are set to 500K. Let's go through some examples of motor motion control. First, let's set speed to 5000. Click Enable. Motor number 6 is running. Its real-time status can also be checked from here. It can be stopped and displaced. Click button. Displacement status can be cleared and will start from 0 when restart. Amount of displacement can also be set. Let's input displacement of 10,000. Input speed here. Now the motor is moving and it will stop after 10,000 displacement. Manage motor breakdown setting. Current, standby current, and boot enable time can all be set. Motor breakdown can be set to the whole, half, 4, 8, 16 subdivision. Current setting is based on model type. 2, 4, 8 refer to maximum current of 2 amp, 4 amp, and 8 amp. Set standby current and self-loose current when the motor is not running. Set power up time from here. Other than control of individual node, all nodes are controlled simultaneously. For overall control setting, first switch all nodes to offline. Then set each node separately and apply their settings. Under global state, input speed. All motors are running under the same speed at the same time. Similarly, by setting displacement, all three motors will stop after 10,000 displacement. Other than global control, step-over also supports coded instructions. Select number 6, send speed instruction. It starts running. Settings for power up and other controls are in this area. Set the motor to be unlocked only after power on again. When blocking emergency stop, offline happened, models can still be controlled by sending instructions. The settings of user program when power on. The function of PG Internal programming is workable. Set direction, clockwise or counterclockwise accumulation. The setting for Power On Auto Enable. 3 output signal S1, S2, S3 can be set from here. Also, P4 port enable is here. For initial calculator, it's adjustable. You can choose level output or analog output. When analog output is chosen, you can choose S1 or S3 for output signal. For encoder enable, control open loop motor even under closed loop status. Control closed loop model directly. Enable advanced motion control from here. Control accelerating and deceleration. Input timing or number. The notification to indicate the changes of the status of S1, S2, S3, and P4. For sensor, both falling and rising edge settings are workable. For example, we can set falling edge for S2, bind it to notify clockwise or counterclockwise continuous and displacement motion. S3 can be bound these actions as well. For P4 output, store or change it based on motion status, speed, directions, etc. Bind lock the rotor here. Actions can be bound: an emergency stop, reverse continuous operation, etc. After binding, you need to store the motion parameters on the offline status. Click here to apply falling and rising edge binding. Save it. Also, save motor parameters of displacement and speed. Save lock the rotor signal. Check the status. For site number 7, bind the falling edge and rising edge of S1 and S2 to reverse continuous operation. For S3, bind it is decelerate to stop. Enable them all. Click S1 button. Model is running at the speed of 5000. Click S1 again. Model will be running continuously in reverse direction. Click S2. Model will be also running continuously in reverse direction. Click S3. Model will decelerate to stop. Accelerate and decelerate can all be set. For example, you can set accelerate to 200 milliseconds. You can pause here and set accelerate to 2000 milliseconds. Restart, model will accelerate at a lower rate. You can also set accelerate as digital input instead of time. Now the setting is 200 pulses per second. Model will start to accelerate at a very low rate. To set encode line speed for 242 series, standard is 500, and this can be customized to 300 or 800. Set lock the rotor. Set automatic gap consumption. Sensor delay setting and shakeout time setting can also be done. By setting S1 sensor ending shaking time to 100 milliseconds, system will give no feedback within 100 milliseconds even as when signals again. This is all for 242 series. Please refer to our menus for details.